Okay, welcome back for day 2 of flipped classrooms. We're going to do 7.6 today. As you can see here, it's solving equations involving radicals. I figured out I got a little circle feature with my stylus. So solving equations involving radicals. Alright, and you see our goal today is going to solve equations with radicals in it. Radical equations and problems that concern radicals. Usually that means like word problems. Alright, and there's one rule we really need you to know. That if I have one number equals another number, and if I raise the first number to a certain power and I raise the second number to that same power, the expressions will still be equal. This will still be equal to that if this is true to start with. This is especially useful for equations with radicals. In particular, we have this, variable equation, kth root of x equals y. If I wanted to solve for x, right, solve for x, how would you do it? You know, one way to think about this is like, let's take a simple example. What if I had the square root of x equals y? Then how would you find x? How would you solve x? How would you get x all alone? Well, you would take both sides and do what to it? Yeah, you're right. You would square both sides. So now you get x. Now you get x equals y squared. Okay, that's a really simple example. What if I took another example? Solve for x, and solve for x, and I had the cubed root of x equals y. Yeah, do it. So show me, what does x equal? Did you get the same thing as I did? I bet you did. Alright, so let's go ahead and say, in general, come back over here, let me use my little spotlight. Over here, the kth root of x equals y. If I wanted to solve for x, now I know x equals y to the k. No matter what k is, that's going to be true, because this was true over here. Alright, next page, or for you, next problem. So here's a very basic radical equation. It's an equation because there's an equal sign. Right, now what I do to one side I can do to the other side. Okay, so I have the square root of 3x plus 4. My radical is all by itself over here, which is crucial. It's already started that way, which is why I called it simple. And so in order to solve for x, which is underneath the radical, it is part of the radicand, which is this binomial here. I want to get this binomial out from underneath the radical. So since it's a square root symbol, I am going to go ahead and square both sides. Because in an equation, what I do to one side, I have to do to the other. So the square root of something squared is simply that something. So that simplifies to 3x plus 4. And then on the right hand side, we end up with 25. Subtract 4, divide by 3, x equals 25 minus 4 is 21, divided by 3 is 7. X equals 7. Now, unfortunately, or fortunately, one of the nice things about this problem is that you can check your work. Unfortunately, sometimes you're going to get answers that don't work, so you have to keep your eyes out for those answers that are going to try and sneak through and make you think that you have an answer, but when you go back and plug it back in, they don't really work. So you have to keep your eyes out for what we call extraneous solutions. Extraneous. So I'm going to ask myself, is this extraneous? And in order to check if it's extraneous, I am going to plug 7 back into the original equation and see if it's true. Is 3 times 7 plus 4 equal to 5? If I take the square root of it. 3 times 7 is 21. 21 plus 4 is 25. This whole thing is 25. The square root of 25 is 5. Check. I like my answer a whole lot more right now. Alright, not too bad, not too bad. Let's take a look at another one. X minus 2 equals the square root of 2x minus 1. My radical is isolated already, so it's all by itself. So I can go ahead and undo the square root. Yep, that's right, by squaring both sides. Now, the trick on this problem is that the other side isn't just a single term like it was over here with a 5. Instead, it's a binomial. So when you square the left-hand side, you have to square the binomial. Okay, the whole quantity x minus 2. You go ahead and do the extra work if you want to. I already know that this is going to be x squared minus 4x plus 4. And for those of you who are about to ask, where did that minus 4x come from? Multiply it out, x minus 2 times x minus 2, double distribute. You'll see where it comes from really fast. Okay, on the right hand side, the square root of something squared is simply the radicand itself. So I get 2x minus 1 on this side. The rest of the problem from here is basic algebra, solving a quadratic equation. Let's set it equal to 0 by moving this stuff over to this side, see if it factors. If it doesn't factor, use the quadratic formula or completing the square. Try the work on your own, come back and check in with me when you're finished. Okay, so hopefully you took the time to do the problem. We move everything over, I end up with the quadratic. It's factorable into minus 5 and minus 1. Therefore x equals 5, x equals 1. Did you remember to check to see if they were extraneous? If not, pause me now and try it. If you did check to see if they were extraneous, then what you'll see is we'll have to eliminate one of these answers. Here in purple, I think this is purple, I check 5. Is 5 minus 2 equal to the square root of 2 times 5 minus 1, and 3 equals the square root of 9? Check, so 5 is an answer. However, when I checked 1, is 1 minus 2 equal to the square root of 2 times 1 minus 1? 1 minus 2 is negative 1, and the square root of 1 is positive 1. So no, 1 turns out to be an extraneous solution. So I'm going to eliminate it as one of my answers and simply highlight x equals 5 as my solution to this radical equation. Alright, that wasn't so painful, was it? Oh, no, look at these. These might be a little more painful. Alright, buckle up. Here we go. We have two radical expressions in this equation. We have the radical expression square root of 3x plus 3 and the radical expression square root of x plus 2. Okay, now in order to solve for x, we do need to get rid of these radical expressions, or at least the radical signs. And you still have to isolate the radical. Both of these radicals are on the same side of the equal sign. So we can't start by squaring both sides yet. However, if I move one of these radicals to the other side, then yes, I will get rid of it. At least one of them. This is like a multi-step process. We have to end up squaring both sides in this problem twice. Alright, stay with me now. Here we go. So I'm going to bring this square root of x plus 2 over to the other side. Okay, so here we go. Ready or not? We're going to need a little bit more room, so I'm going to scratch these problems out. You know, maybe you're going to want to do your work on a separate sheet of paper or in a notebook or something. I don't know, but this problem is going to take a little bit of space because we have two radical expressions here in our equation, and the beginning process is still the same as it was before. We need to get a radical expression all by itself on one side of the equal sign. I have two radical expressions on this side, so I need to bring one of them over to the other side, so that way I get only one on this side. And so unfortunately, when I do that and I square both sides, there's still going to be a radical expression on this side, and we'll end up having to square both sides again. So that's why it takes a little bit of space. We just have to do the process twice when we see two radical expressions. Okay, so I'm going to subtract the square root of x plus 2 from both sides, minus the square root of x plus 2. And that leaves me with, whoop, stay over there. And that leaves me with, what are you doing? Boom. Alright, so what does that leave me with? That leaves me with the square root of 3x plus 3 on this side equals 5 minus the square root of x plus 2 on that side. Alright, oh, I like this purple color before, I'll use it again. Now I have this radical all by itself, and when I square both sides, the radical and the square cancel each other out, and I'm simply left with the radicand of 3x plus 3. That now equals, oh boy, 5 minus the square root of x plus 2, the whole quantity squared, right? The whole quantity squared. So we're going to need a little side work over here. This is going to be 5 minus square root of x plus 2 times 5 minus square root of x plus 2, because as we know, when you square a binomial, it means to multiply it by itself. So here we go. Let's multiply it by itself. Double distribute. Multiply the 5 times the 5. Multiply the 5 times the negative square root of x plus 2. So I get minus 5 times square root of x plus 2. Then come over here, multiply the negative square root of x plus 2 times 5, and once again I get minus 5 times the square root of x plus 2. And now we get negative square root of x plus 2 times negative square root of x plus 2, so I get a positive square root of x plus 2 squared, and those will cancel out. So the square root and the square cancel out, and I left with x plus 2 there. These are considered like terms. Minus 10 times the square root of x plus 2, and the 25 carries down. So here we have 25 minus 10 times the square root of x plus 2 plus x plus 2. I can combine the 2 and the 25, and I'm going to reverse the order a little bit. I'm going to write the x first. So this x is going to come down over here, and I'm going to write it here. Now I'm going to bring the minus 10 square root of x plus 2. There we go. And then I'm going to bring the 25 and the 2 over here and write it as a 27. Oh, I forgot the 10. Man, oh man. Alright, so x minus 10 square root of x plus 2 plus 27. Alright, so now I'm going to take this and put it in place of this right here. So I'm going to oh, no, I'm not. I'll just rewrite it. Alright, so x minus 10 square root of x plus 2 plus 27. Put my little separator there. And now we have, look at this, an equation with a radical in it. We're going to call this a radical equation. Let's isolate our radical and square both sides. So it's kind of like starting a problem all over again. Yay! Alright, subtract 27. Subtract 27, I get negative 24. Subtract x, I get 2x. That's equal to negative 10 times the square root of x plus 2. Let's shift down a little bit. You with me? If not, go back and kind of redo the steps, even if you need to do it on scratch paper, just to kind of, can you get this this trinomial over here? This is hard work, so fight through these steps. See if it makes sense to you. If not, try to rework it. Okay, squaring both sides got me this. I combined like terms. I subtracted x. I subtracted 27. This is exactly the same. So now what I'm going to do is, well, I got a couple choices here. I see that there's a factor of 2 in here, so I'm going to factor out a 2 and divide both sides by 2. And I get x minus 12. Now if I divide this side by 2, I divided this side by 2, so that gets me negative 5 x plus 2, and I'll go ahead and show it. Divide by 2, divide by 2. Okay, remember the Hart method dividing by a monomial. Good. Alright, now here we go. Let's go ahead and square both sides. We could divide by negative 5 if we wanted to, but it just creates extra work in the long run. So I'm just going to suggest that we square both sides right here. Square, square. Alright, here we go. Ready? X squared minus 24x plus 144 equals, and on this side I get negative 5 squared, which is 25, and I get square root of x plus 2 squared, which is simply x plus 2. Alright. Okay, I jumped ahead a little bit because my time is about to run out. Go ahead and finish up this problem, and meet me in class tomorrow. We'll talk about the answer. Here's where negative 24 came from, in case you're wondering.